Hello, my name is Andrew Kessler, and today I'm going to be talking about the Adidas Boost running shoes and the Adidas Boost technology. Why Boost? Well, I became interested in running as a high school freshman. I was recommended to the shoes by my teammates. I first tried them sophomore year, and I fell in love ever since. I like them mostly because of all the technology aspects and the materials that I'll talk about later in the slideshow. What is Boost? Boost is a revolutionary cushioning technology that delivers the highest energy return of any running shoe currently on the market. Boost cushioning is made from thousands of specially formulated foam pellets called energy capsules. Essentially, all the specs and materials of the product make it better than the traditional foam used in most running shoes called EVA. This type of boost was developed by a company known as BASF, and I'll talk about their research on the next slide. The picture on the right shows a typical Boost shoe, and it zooms in on the Boost material, which is the white pellets in the circle, and zooms in even farther into the materials, but I'll show that more later. About BASF's research. The goal of their research was to find a plastic with high elasticity and deformability for a reasonable price. They developed the world's first expanded thermoplastic polyurethane, or eTPU, and labeled it Infinergy. They basically made this by expanding the typical thermoplastic and adding it to typical properties of foam. The benefits of this product: low bulk weight, little water absorption, high tensile strength, and good chemical resistance. Chemical resistance is a very important aspect for running shoes, as you want your running shoes to last a long time through countless materials and different environments. So a long-lasting and good resistant running shoe is very important. The picture is one of the zoomed in pictures from the last slide, and it shows the elastic nature of the eTPU and connects it with the elastic nature of the rubber-like units that hold them. This picture shows both the tensile strength and elasticity of the running shoe material. So stress tests are very important in determining the running shoe. It leads to excellent recovery behavior due to closed cell structure of the foam. The material performs 75% better than other foam when used under continuous load. This shows that Infinergy returns a lot of its energy, especially as compared to its competitors that's applied to it. Even more interesting, the results remain consistent for a wide range of temperatures, specifically -4 to 104 degrees Fahrenheit, which somewhat correlates to what the temperature range of a St. Louis day could be. This showed a 3 times better temperature resistance and deformation as compared to the leading competitors. Stress tests are important because, depending on your running style, a typical human will exert 2 to 3 times their body weight for every strike of the foot on the concrete that they put. Therefore, running shoes have to put up with a lot of stress, especially throughout a run and the running shoe's life. Stress testing a running shoe is very important and will lead to good results, especially as it relates to how long a running shoe can last in its lifetime. Applications to Adidas. So the stability and energy return of the shoe greatly improves an athlete's biomechanical output. I won't really talk about the biomechanics, especially in this video, but essentially the energy efficient nature of the shoe will lead to a greater energy efficiency of running. They also add a striking and unique design to the newly renovated Adidas brand that's becoming ever more popular and starting to compete against big brands like Nike and Brooks. Boost likes to use this demo as an example of their energy return. Essentially, they drop a metal ball onto a test surface known as concrete and then onto the EVA and Boost foams. What it shows is that their energy return in the height, based on the height rebound, is about 55% for Boost, as compared to about 20 to 30% for the EVA. This clearly demonstrates that the Boost material returns a lot higher energy output than the EVA. While this isn't exactly perfect because energy return is variable, it's a good demonstration for the raw output based on the energy shoe. Benefits beyond the Boost. So the material design and just the striking aspect of the shoe is quite unique. As you can see on the top, there's a stretchy, breathable mesh material right about here. And this allows for running shoes to let your foot breathe, which is also adds to comfortability when you're running. The stripes along the side, which is typically known as the Adidas brand, is also used for stability ends on the side of the shoe. Typically, along with the foam on the bottom, this adds a striking and unique feature to running shoes. Adidas is really revolutionizing their brand with these types of shoes and is really changing the running shoe market as a whole. So the value of energy return. Energy return itself is only useful if it's substantial enough to make a difference for a runner, and it's returned at the right time, frequency, and location. Therefore, each shoe must be designed for an excess number of variables, i.e. weight, speed, and foot strike. Boost's additional long line of products helps account for these variables, and people choose which product fits them best. Adidas recently concluded a study and found that the Boost midsole lowers energy consumption by about 1% for a runner as compared to the EVA shoe. While this doesn't seem like much, over a 3-hour race, this can make a striking difference in the energy return that a person's able to output. These two designs show the energy output in the stress test that Adidas tests on their shoes. The top right picture shows again the location aspect of an energy output and how different foot strike can lead to a different energy output, so maximizing their shoe for each individual foot strike can be very beneficial for a runner. The left picture shows more of a stress test. The area in between the increasing force and the decreasing force is the return percentage of that energy output. Therefore, increasing the increasing force while remaining the decreasing force the same, or decreasing the decreasing force, will lead to much greater energy output in a shoe. Thank you.